What happens is, as this rocket moves vertically upwards, there is an internal explosion that happens here, causing this part to move downwards, and this one continues to move upwards. Okay, so in this problem here, we are given a rocket system that has two parts. So the first part has a mass of 3m, and the second part, which is B, has a mass of 2m, as shown in the diagram here. So now we are asked to state the principle of conservation of momentum. So that is your 4.1. So the principle of conservation of momentum states that the total linear momentum in an isolated system remains constant. So when you talk about the total linear momentum, we're basically talking about, we can say, the sum of momentum, which can be your P1 plus P2 depending on the system. And then we're talking of an isolated system, we're talking of a system that is free from external forces, right? The second statement says that the rocket traveling vertically upwards at a constant speed v, when an internal explosion causes A to move downwards at a speed of 1/3 v, right? So what happens is, as this rocket moves vertically upwards, there is an internal explosion that happens here, causing this part to move downwards, and this one continues to move upwards. So 4.2 says that calculate the velocity of B in terms of V immediately after the internal explosion. So what you're going to do is we're going to first write down the information that we have. 4.2. So for part A, we know very well that the V initial is equals to V. The V final of part A, we know very well that it's 1/3 V, which is this one here, 1/3 V. And the mass of A we are given as 3m, which is this one here. Then for part B, we know that the initial velocity is also v. The v final we don't know, which is what we want to calculate, but we know that the mass of B is given as 2m, which is this one here. So we are asked to calculate the v final of part B. So the first thing you're going to do is you're going to use this equation here, which is mv A initial plus mv B initial is equals to mv A final plus mv B final. So you're going to use this momentum equation. Now, before we substitute the values of part A and part B, we first need to make an assumption that upwards is positive and down is negative, right? So before collision, the entire system is going upwards. So this means that we're just going to substitute the values as positive. So the mass of part A is given as 3m, and the velocity of part A is given as v, plus the mass of part B is given as 2m, the velocity of part B is given as v, equals to, so the mass of part A is 3m, and the final velocity of part A is given as 1/3 v. So 1/3 vy, okay, fine, we are given it's 1/3 v here, but we also know that part A is now going downwards after the collision or after the explosion, right? So what we need to do is we need to put a negative 1/3 v here, plus the mass of part B, which is equals to 2m, and the v final of part B, which is what we are looking for. So what's going to happen here is you're going to have 3mv plus 2mv is equals to, so this 1/3 here is going to multiply this one here, so you're going to have minus mv, because this 3 here is going to cancel out these 3 here, and then you have plus 2mv final of B. So when you add these two here, you're going to get 5mv is equals to minus mv plus 2mv final of B. Then you're going to take the minus mv the other side, you're going to have 5mv plus mv is equals to 2mv final B. Then when you add these two, you're going to have 6mv is equals to 2mv final of B. Then you're going to divide by 2m, you're going to have v final of B is equals to, so this m here is going to cancel out this m, and you divide 6 with 2, you're going to have 3v. So this is just going to be your final velocity for part B, which is positive, meaning that it's upwards.
Thank you so much for watching. If you have any questions, suggestions, or comments, please write them in the comments section below. Don't forget to subscribe to the channel for more videos.